The first Meaty problem asks us to use IVT to prove that f of x has at least two zeros on the closed interval -1 to 1. The first method we can use to solve this is to expand this as a partial sum. So we can say f of x is approximately 4 minus 4 to the third over 3 factorial x squared plus 4 to the fifth over 5 factorial x to the fourth minus 4 to the seventh over 7 factorial x to the sixth plus 4 to the ninth over 9 factorial x to the eighth. This should be enough terms. Next, what we want to do is realize that this is an even function, meaning that it's going to be symmetrical across the y-axis. That means if we can prove that there is a 0 between -1 and 0, then there must be a 0 between 0 and 1. So first we need to find out if f of 0 is positive or negative. F of 0 is, once we plug in 0 for x, all these other terms go away and we're left with the first term, which is 4, greater than 0. Next, we can approximate f of -1, but we can realize that this is an even function, meaning that f of -1 is also equal to f of 1, and this is approximately 4 minus 4 to the third over 3 factorial, etc. One common mistake would be forgetting to incorporate the alternating series error, and when you only do the first two terms, you realize that this is a negative number, and that's what you want. You want to prove that f of -1 and f of 1 are negative, because f of 0 is positive. Therefore, that means there has to be a 0 between -1 and 0. However, once you include the alternating series error, the maximum of which is going to be the absolute value of the next term, once you add that, it's actually a positive number, meaning the maximum value for f of -1 and f of 1 is positive, and we need to prove that it's negative. So we have to go through another term. Once we go through 4 terms, we find that this is equal to -1.384. However, once we incorporate the alternating series error, which is the absolute value of the next term, that is 4 to the ninth over 9 factorial, which is 0.722. So next we have to add what we approximated to the maximum error, and this gives us our maximum value for f of -1 and f of 1, and this is -0.662. Because f of -1 and f of 1 are a negative value, and we know f of 0 to be positive, then there must be a 0 between -1 and 0. And by symmetry across the y-axis, that means there has to be at least one 0 between 0 and 1 as well. Another method to solve this would be to identify what function this summation represents. If we look in the denominator, we see 2n plus 1 factorial. This is indicative of sine of x, which also has this in the denominator. However, sine of x has x to the 2n plus 1 power, and this only has x to the 2n power. So we can multiply by x, which is just 1, to get x to the 2n plus 1 power. So we can say f of x equals the summation from 0 to infinity, the alternating series, 4 to the 2n plus 1, x to the 2n over 2n plus 1 factorial times x by x. We can move this x over into the x power here, so we can say x to the 2n plus 1. Now we're left with the 1 over x. Since 1 over x is independent of n, we can just move that to the front of the summation. So this is now equal to, and once we combine these, we can say this is 1 over x times the summation of 4x to the 2n plus 1 over 2n plus 1 factorial. Now this is more recognizable as a sine function, with 4x being what's inside. So this is 1 over x times sine 4x. However, one common mistake would be to just leave this as f of x, but we have to recognize that this has a discontinuity at x equals 0, but this summation is continuous at x equals 0. If you remember from the previous method, we found f of 0 equals 4 directly from this series. So we have to define f of x as a piecewise function, such that it is sine 4x over x when x doesn't equal 0, and it is 4 when x equals 0. Now we know that f of 0 equals 4, And we can also plug in directly for f of -1 and f of 1, which is sine of 4 over 1, which is negative 0.757. Again, using the same principle from the previous method, because f of -1 is negative and f of 0 is positive, there must exist a 0 between -1 and 0. Then by symmetry across the y-axis, there also has to exist a 0 between 0 and 1. A thorough justification would be that because f of x is continuous and differentiable for all x, f of -1 is less than 0, and f of 0 is greater than 0, intermediate value theorem guarantees that there must exist a c on the closed interval -1 to 0 such that f of c equals 0. By symmetry across the y-axis, there must exist a d on the closed interval 0 to 1 such that f of d equals 0. Therefore, there must exist a c and a d where c equals -d between -1 and 1 such that f of c equals f of d equals 0. The second Meaty problem tells us that a person walks along the graph r equals 2 plus sine 2 theta and collects this amount of money for every point r comma theta he walks through. We are asked to find how much money he makes after completing one loop around the graph. This is just a quick drawing of the graph. He starts at 0 and he moves along, and for every distance s he travels, this is how much money he makes. So we can define a function m of s, where m is the money collected and s is the distance traveled. We are also given that he starts with $0. To solve this, first we need to interpret this rate as something in terms of m and s. This is how much money he makes, the rate of money he makes, which is dm, for every point walk through ds. ds can be interpreted as an infinitely small line segment along the curve, which would just then be a point, which is why ds would be every point he walks through. So dm ds is the absolute value of 3 sine theta times r. We can just plug in what we already have for r, which is 2 plus sine 2 theta. Next, we need to find what ds is in terms of theta, because what we want to do is get everything in terms of dm. We want to get dm in terms of theta, because then we can integrate and find how much money he made. So we can say dm equals absolute value of 3 sine theta, 2 plus sine 2 theta ds. And what is ds? Well, we know what s is based on the polar arc length formula, so we can say s is the integral from 0 to theta of the square root r squared plus r prime squared d theta. In order to find ds, we want to take d by d theta of both sides, and by the fundamental theorem of calculus, this just gives us the integrand. So ds by d theta is r squared plus r prime squared. Next, we can plug that in for ds, but we found ds d theta, so in order to find ds, we can just move the d theta to the other side. So dm is our rate function times ds, which is the square root of r, which is 2 plus sine 2 theta squared, plus r prime squared, which is the derivative of this, is 2 cosine 2 theta, and d theta. Next, we need to find what interval we're going to integrate on, and because it said how much money he makes in one loop, he makes a loop from 0 to 2 pi. So we can integrate both sides, 0 to 2 pi. And one thing we can recognize is that this is a cyclic function. It makes a loop for every 2 pi. And because we're integrating along a closed loop, this can be specified as a closed line integral. This value returns $63.97. The second part of the question asks us to use extreme value theorem to find the absolute extrema of m on the closed interval 0 to 2 pi. First, we'll take the m of s function that we thought of earlier and turn that into an m of theta function, because s is just a function of theta. This helps because we found the dm d theta derivative, and we can use that for the first derivative test, which is a part of the extreme value theorem. So we can take the dm ds, that rate that we were given, times ds d theta, which is from the polar arc length formula, which gives us dm d theta. We already found this in the previous part, and this is 3 sine theta times 2 plus sine 2 theta times the square root of 2 plus sine 2 theta squared plus 2 cosine 2 theta squared. If we were to integrate this, we would move this d theta over to the other side, which is exactly what we did, but we just need the derivative here. Next, we can find where this derivative is equal to 0 or undefined on this interval. This happens at 0, pi, and 2 pi. Now we can create a table with the critical points of m of theta and m of theta itself. So we can put 0, pi, 2 pi on the left and find what m of these theta values is. M of 0 is 0 because we were given that he starts out with $0. M of pi would be the integral from 0 to pi of dm, and this is equal to $31.99. We already calculated the integral from 0 to 2 pi of dm, which was $63.97. Now we've completed the first derivative test using this table as a justification. We can say that the absolute min is 0 and the absolute max is $63.97. A common mistake using extreme value theorem would be forgetting about the endpoints, and as we can see here, the endpoints are especially crucial because both of these endpoints are the absolute extrema, so we can't just consider the critical points inside the interval itself. Another way to think about this would be to realize that m of theta is a monotonically increasing function. That is because dm d theta is always greater than or equal to 0. If we look at this derivative, it's an absolute value function times a square root function, meaning that it has to be positive or equal to 0. Just taking a random monotonically increasing function, the absolute extrema of this are evidently the endpoints, with the absolute min being the lowest one and the absolute max being the highest one. This exactly relates to m of theta because the lowest endpoint is the min and the highest endpoint is the max. This same thing holds for any monotonic function where the endpoints are going to be the absolute extrema.